Every year, the world produces over 400 million tons of plastic. This staggering amount is equivalent to the weight of the entire human population. Factories around the globe are churning out plastic products at an unprecedented rate, contributing to a growing environmental crisis. And yet, less than 10% of that gets recycled. Despite the efforts to promote recycling, the infrastructure and public awareness are still lacking. Most of the plastic ends up in places where it shouldn't be, causing significant harm to our planet. According to the Environmental Protection Agency, only about 8.7% of plastic waste was recycled in 2018. The rest? It ends up in our oceans, landfills, and even in the food we eat. Microplastics have been found in fish, shellfish, and even in the salt we use daily. This contamination poses serious health risks to both marine life and humans. A study by the University of Newcastle estimated that an average person could be ingesting approximately 5 grams of plastic each week. That's the equivalent of a credit card. Plastic pollution has become one of the most urgent environmental challenges of our time, threatening wildlife, ecosystems, and human health. Animals often mistake plastic for food, leading to fatal consequences. Communities worldwide are coming together to clean up beaches and reduce plastic use, but much more needs to be done to tackle this global issue. As Dr. Jenna Jambeck, a leading environmental engineer, states, we need to rethink our relationship with plastic and develop sustainable solutions to prevent further damage to our planet. The journey of biodegradable plastics began decades ago. Early experiments aimed to reduce plastic waste, but science is fighting back with biodegradable plastics. Unlike traditional plastics that can take hundreds of years to break down, biodegradable plastics are designed to decompose naturally under the right conditions. These materials can be broken down by microorganisms such as bacteria and fungi through a process called microbial digestion. This process converts the plastics into water, carbon dioxide, and biomass, leaving little to no toxic residue behind. For example, biodegradable plastic bags used in composting facilities break down completely within a few months, enriching the soil without harming the environment. So how do they work? The answer lies in the intricate world of chemistry, where scientists have developed innovative methods to create materials that can break down naturally. It all comes down to chemistry. By understanding the molecular structure of traditional plastics, researchers have been able to design alternatives that are more environmentally friendly. Biodegradable plastics are often made from renewable resources like cornstarch, which is abundant and can be easily converted into polymers. Sugarcane, which provides a high yield of fermentable sugars, or even seaweed, a resource that doesn't compete with food crops and grows rapidly in marine environments. Others are synthesized to mimic natural polymers. These lab-created materials are designed to have similar properties to conventional plastics, but with the added benefit of being biodegradable. Two common types of biodegradable polymers are polylactic acid, PLA, and polyhydroxyalkanoates, PHI. PLA is derived from fermented plant starch, typically corn, and is known for its clarity and strength, making it ideal for packaging and disposable tableware. PHA, on the other hand, is produced by microbial fermentation of sugars or lipids. It is highly versatile and can be used in a wide range of applications, from medical devices to agricultural films. Their key trait: a structure that breaks apart more easily in the presence of enzymes and microbes. Whether it's industrial composting, home composting, or even marine degradation, these plastics are engineered to decompose efficiently. These plastics are made to disappear. Over time, they break down into water, carbon dioxide, and biomass, leaving no toxic residue behind. This makes them a promising solution to the growing problem of plastic pollution, offering a way to reduce our environmental footprint while still enjoying the convenience of plastic products. There are many types of biodegradable plastics, each with unique properties and applications. Understanding these types can help us make more informed choices about the materials we use in our daily lives. PLA, polylactic acid, comes from fermented plant starch, typically derived from corn, sugarcane, or cassava. This bioplastic is popular due to its renewable origins and is often used in packaging, disposable tableware, and even 3D printing. It's used in food containers and disposable utensils, providing a more sustainable alternative to traditional plastics. However, PLA requires industrial composting facilities to break down effectively. PHA, polyhydroxyalkanoates, are produced by microbial fermentation and are marine biodegradable. This means they can break down in marine environments, reducing the impact of plastic waste on our oceans. PBAT and PBS are fossil-derived but engineered to be compostable. PBAT is often used in compostable bags and agricultural films, while PBS is used in packaging and disposable items. Each type of biodegradable plastic has its strengths and drawbacks. For instance, while some are derived from renewable resources, others still rely on fossil fuels. Some break down quickly but are expensive to produce, making them less accessible for widespread use. This cost factor can be a significant barrier to adoption. Others are versatile and can be used in a variety of applications but need high heat composting to decompose properly. This means they won't break down in a regular home compost bin, requiring specialized facilities. Starch-based bioplastics are another category, often used in biodegradable mulch films and packaging. These materials are derived from crops like potatoes and maize. Cellulose-based bioplastics made from plant fibers are used in biodegradable films and eco-friendly packaging. They offer a renewable alternative to petroleum-based plastics. Algae-based bioplastics are an emerging type, offering sustainable options for packaging and other innovative products. These bioplastics are derived from algae, which grow quickly and don't compete with food crops for land. The future of biodegradable plastics is promising, with ongoing research and development leading to new materials and applications. As technology advances, we can expect even more sustainable options to become available. Biodegradable plastics are already replacing traditional plastics in packaging, agriculture, textiles, and even electronics. Startups are creating seaweed-based film wraps. Researchers are experimenting with mushroom mycelium, and companies are developing biodegradable phone cases, shoes, and clothing. In healthcare, biodegradable medical implants and eco-friendly surgical tools are emerging.
Biodegradable plastics are revolutionizing the medical field, says Dr. Jane Smith, a leading researcher in sustainable materials.
The automotive industry is also seeing innovations with biodegradable car parts.
We're developing car components that can decompose naturally, explains John Doe, an automotive engineer.
The market is booming. With rising eco-awareness and growing bans on single-use plastics, bioplastics are expected to grow exponentially in the coming decade. Major brands are investing in compostable packaging. Entire cities are trialing plastic-free grocery aisles. The global bioplastics market is projected to reach $20 billion by 2025, growing at a compound annual growth rate of 15%. Innovations in technology and increased funding are driving this growth, making bioplastics more accessible and affordable. But challenges remain. Biodegradable doesn't always mean it breaks down everywhere. Some plastics labeled biodegradable still need special facilities. Infrastructure must catch up. Policies need to regulate labeling and certification, and production must scale sustainably without competing with food crops. Economically, scaling up production can be costly. Environmentally, it risks deforestation and monoculture farming. We need innovative solutions and community efforts to balance these impacts. Still, the future is bright. With innovation, education, and policy support, ongoing research and development are paving the way for more efficient and versatile biodegradable plastics. These advancements could drastically cut our dependence on fossil-based plastics and reduce long-term pollution. It's not a silver bullet, but it's a critical piece of the sustainability puzzle. Biodegradable plastics are more than just a buzzword. They're a growing solution to a global crisis. And if nurtured correctly, they might just help build a cleaner, greener future for all of us. Let's support biodegradable plastics and make more sustainable choices today. Together, we can make a difference. Understanding the life cycle of biodegradable plastics is crucial to appreciating their environmental benefits. First, it all begins with the production phase. Unlike traditional plastics, biodegradable plastics often start with renewable resources like cornstarch, sugarcane, or even potato starch. These natural materials are processed and transformed into bioplastics through complex chemical processes. Next, we move to the usage phase. Biodegradable plastics can be used in a variety of applications, from packaging and disposable cutlery to agricultural films and medical devices. Their functionality mirrors that of conventional plastics, but with a key difference. They are designed to break down more easily after use. Once these products have served their purpose, we enter the disposal phase. Here, the magic of biodegradation begins. In the right conditions, such as industrial composting facilities or even home composting bins, microorganisms start to break down the bioplastics into water, carbon dioxide, and biomass. This process can take anywhere from a few months to a couple of years, depending on the type of biodegradable plastic and the disposal environment. Finally, the end products of this decomposition process return to the earth, enriching the soil and closing the loop on a sustainable life cycle. This stands in stark contrast to traditional plastics, which can persist in the environment for hundreds of years. By understanding and supporting the life cycle of biodegradable plastics, we can contribute to a more sustainable future. So, the next time you come across a biodegradable plastic product, remember the journey it has taken from production to disposal and appreciate the positive impact it has on our planet. Thank you for watching, and let's continue making informed choices for a greener world. As we delve deeper into the world of biodegradable plastics, it's vital to consider their economic impact. Beyond the environmental benefits, biodegradable plastics are creating new market opportunities and job prospects. Firstly, the production of biodegradable plastics often relies on agricultural products such as corn, sugarcane, and potato starch. This creates a positive ripple effect in the agricultural sector, boosting demand for these crops and supporting farmers. In addition, as the biodegradable plastics industry grows, so does the need for specialized manufacturing facilities. This has led to the establishment of new factories and production plants, creating jobs in engineering, manufacturing, and quality control. These facilities are often located in regions that benefit from economic revitalization, providing employment and stimulating local economies. Moreover, the research and development sector is experiencing a surge in activity. Scientists and engineers are continuously working on innovative ways to improve the performance and cost efficiency of biodegradable plastics. This ongoing R&D not only advances the technology but also creates high-skilled jobs and fosters a culture of innovation. The retail and logistics sectors are also seeing new opportunities. As consumer demand for sustainable products rises, retailers are expanding their eco-friendly product lines, requiring new supply chain strategies and marketing approaches. This shift opens up roles in sales, marketing, and supply chain management focused on sustainable products. Additionally, the market for biodegradable plastics is expanding globally. Companies that produce and distribute these materials are tapping into international markets, creating export opportunities and contributing to economic growth on a larger scale. In summary, the rise of biodegradable plastics is not just a win for the environment, but also a significant economic boon. By fostering job creation, supporting agricultural industries, and opening new market opportunities, biodegradable plastics are paving the way for a more sustainable and prosperous future. Thank you for joining us on this journey through the world of biodegradable plastics. Let's continue to support innovations that benefit both our planet and our economies. As we explore the multifaceted world of biodegradable plastics, it's crucial to highlight their environmental impact. These innovative materials offer a promising solution to some of the most pressing ecological challenges we face today. To understand the true environmental benefits, let's delve into some compelling case studies and success stories from around the globe. In the coastal town of Plymouth, England, a local initiative replaced traditional plastic packaging with biodegradable alternatives made from seaweed. The result? A significant reduction in plastic waste, washing up on the shores, preserving marine life and protecting the local ecosystem. Moving to the United States, the city of San Francisco implemented a city-wide ban on single-use plastics, promoting the use of biodegradable plastics instead. This pioneering move has led to a dramatic decrease in landfill waste, with compostable materials breaking down naturally and enriching the soil. In Brazil, a biodegradable plastic made from cassava starch is revolutionizing the agricultural sector. Farmers are using this eco-friendly alternative to traditional plastic mulch films, which decompose naturally, leaving no harmful residues in the soil. This innovation is not only reducing plastic pollution, but also enhancing soil health and crop yields. These success stories illustrate the tangible environmental benefits of adopting biodegradable plastics. By reducing plastic pollution, conserving natural resources, and promoting sustainable practices, biodegradable plastics are playing a pivotal role in protecting our planet for future generations. But the journey doesn't stop here. Continuous innovation and widespread adoption are key to maximizing the positive impact of biodegradable plastics. As we embrace these eco-friendly alternatives, we can look forward to a cleaner, healthier, and more sustainable world. Thank you for joining us in this exploration of the environmental impact of biodegradable plastics. Together, we can make a difference and pave the way for a brighter future.